Okay, so let's just start the stream and welcome to psychology revision sessions. Okay, that's good. Okay, so um, we're going to yay! I'm so sorry. Okay, let's just start. We're going to start with overview, introduction, quantitative versus qualitative, and common terms to know, just to review a bit. And then we're going to go into ethics and then quantitative research, and then afterwards we're going to do qualitative research. By the way, if you guys have any questions, feel free to ask me. Okay, so um, overview. As you guys may have known, psychology means the scientific study of behavior and mental processes. On the other hand, behavior means observable actions, and mental processes means thinking, cognition. Well, as you may also know, a way to study behavior and mental processing scientifically is from good theories and study that supports a theory. And well, as you guys may already know, these are what makes a good theory. That is, it has to be based on a hypothesis, it has to be backed up by evidence, it has to be testable, and it has to be based on a series of assumptions or principles that define a way of thinking for behavior. Alright, so when we say backed up by evidence, in IB psychology we mean by studies, which is the research that people do. And usually it would contain aim, procedure, results, conclusion, and findings. And two important research methods that is significant in psychology would be quantitative and qualitative study. And as you can see here, here's the difference between quantitative and qualitative studies, which is totally not stolen from the IB Psychology Oxford book. Okay, so you can clearly see that the main difference between the quantitative study and the qualitative study would be that the quantitative studies takes an objective approach. So basically what we mean by objective approach is that we use numbers, data, and we quantify them, we calculate them to observe so we I'm sorry, I need to think for a while. Okay, so we count I'm so sorry, my brain kind of fucked up a little. Okay, so for quantitative studies, you use quantitative data, and how you get them is through variables. And these variables are done, these variables are turned into like objective approach by operationalizing them. And we will explain further later about that. And in the other hand, for qualitative study, you focus on text, human experiences, and it's all more subjective because we want to see how behavior takes its context instead of how behavior can be quantified. Okay, so other terms that we have to know would be sampling, which means a small amount of individuals, which are used in experiments to represent the target population. And credibility, that is, whether the studies are reliable enough to be trusted. And usually, if these studies lacks credibility, it means that it has bias, because as we'll explain bias later about why it's like that. And another term would be generalizability, which is how far the results can be used in other situations. So usually in psychology, the more generalizable a study is to the population, the more reliable it is, because it means that the study reflects real-life situations. Usually the more reliable it is. You see, usually in psychology, you have this thing called variables. Well, it's supposed to be explained later, but okay, so a variable is basically a condition, like some kind of characteristic or trait. And usually in experiments, you have to define what these things are. And how you define these variables is that you use construct. So since usually behavior or a certain usually when you have behavior, it cannot be directly observed. For example, you have aggression. You cannot immediately observe this variable, so you create a construct of it, which is like an explanation, a broad explanation of what the aggression is. And in the process of that, you'll have to operationalize what this construct is. Basically, what that means is that you're going to have to define. You're going to have to explain how these variables can be tested. For example, in aggression, there's this one study that defines aggression as like a certain behavior. For example, raising your voice. So I'll just go back to Discord for a sec, and I'll give you the. Oh, okay, never mind. I thought I heard something else. I'll give you access to the slide because I think I forgot about giving access to the slide. Wait. Oh wait, it's right. Okay. Yeah. There. Let me access it for a while, and it's loading. Oh god, okay, there you go. Wait, what is happening? It's lagging. Okay, so I have just opened access to the presentation. Oh, I've seen someone accessed it. Did it work? Hopefully it worked for you. Yeah, I think, okay, yeah. Okay, I think it works now. So, there are additional terms that you don't. Oh, you're welcome. Okay, so there are additional terms that you don't necessarily have to know, but you may know for. Oh. Okay, so there's something. There's some. Okay, so it's probably. You probably have to kind of solve that problem. Okay, so let's just continue. Some additional terms you need to know is retrospective is basically just asking for past behavior. Prospective, measuring from now till future. Longitudinal research would be repeated observations from like for a long period of time. And cross-sectional research would be like analyzing data from different populations in a specific point of time. Like, for example, which I put there, measuring something in the 20 years age group, and then the 40 years age group, and also the 60 years age group in the same time. All right, so now we're going to go into ethics. Ethics are moral principles when carrying out research for correct conduct. So it's important to follow ethics in general because we are experimenting on humans, and experimenting on animals itself is already immoral to some extent. And it's even worse if we experiment on humans, because if we experiment on humans, there might be possible harm that would be exposed to those people. And this can be dangerous because it might have severe long-term effects to these participants. In addition, if this happens and keeps on happening, it can create a big distrust in the psychology field because they would think that, oh, psychology makes people psychology harms people, which is a bad thing. And okay, so now we'll review the ethical considerations, which is the ethical considerations when doing the study and ethical considerations in reporting the results. And as you can see here are the list of considerations that you have to take into account when you're evaluating ethical concerns. So, as you may know, informed consent means that you have to make sure that the participation is voluntary and that the sample knows that their involvement in studies is for a specific reason. And they have to make sure to know that whatever they do in the experiment, it's out of their it's from their will. So it's not something that they are forced to do. And if there are minors who would which are necessary to join an experiment, then they would need parents' consent. And like I said before, there needs to be protection from harm. So participants will need to be protected from physical and mental harm at all times. Because if we affect them in a bad way, that means that it would be bad for them, and it will also be bad for us. Okay, so anonymity and confidentiality. So we have to so basically an ethical consideration that we have to do is that we have to make sure that the participants' data stays confidential, and we have to make sure that their identity isn't linked back from the studies that we had. Because if we expose their identity or their anonymity, that means it might risk their identity. Because in some experiments, there might be some stigma or some sort of bad side effects if be exposed that they joined this experiment. And we should another thing is that we should make sure that participants are allowed to withdraw anytime if they would like to withdraw. Because again, everything they do should be voluntary. If they feel like they're not comfortable with doing any of the experiments, they're allowed to withdraw. And another one would be deception. So in certain circumstances, we're allowed to use deception so that we can gain the results that we want. But it generally shouldn't be done because we're supposed to be honest to the participants if they would like to be willing to conduct our study. But otherwise, if we're using deception, we must explain in debriefing of what our actual nature, aim of study, and data will be used. So we must make sure that the participants are given proper help if they need it. So we talked about how deception are kind of allowed in certain circumstances, and this will explain how or when it's allowed. So if some ethical considerations need to be broken, relaxing them can be done if the study can potentially reveal scientific information that can benefit a lot of people, or if there's no way the experiment can be conducted without relaxing ethical standards. This means that yes, deception or some harms are allowed, but it's only allowed when the ethics committee allows you to do it. And those are for the cases when things are in the gray area. In addition, there's also ethical considerations when you're reporting the results. One would be data verification, which is quite self-explanatory right there. That means that you're faking data or modifying the data to suit your expectations or suit what you believe. And there's also plagiarism, which is copying other people's works. In addition, when you publish a study, the authorship should reflect how much someone contributed to the study. So, like if a professor helps their students do the student's thesis, that means the student is going to be the author and the professor is going to be the co-author. So even if the professor is popular, it doesn't necessarily mean that the professor deserves the author credit, because it depends on how much you contribute to the study. So if there are other scientists who would like to conduct a similar study or who would like to replicate your study, as a researcher, you shouldn't withhold data. You should share your data because sharing data is for the general scientific good, so that they can have a chance to improve their scientific discovery and improve the scientific world. And it is also important that when you handle sensitive personal information, especially in genetic research and related to mental disorders, reporting the results should be worded correctly, or it should be handled with care, because it might affect participants in a bad way. For example, when you have studies involving twin genetics or health status, certain results might affect these people badly, even though we did not intend it to happen. And when it comes to mental disorders, sometimes when you report studies, for example, a study like this would be how depression is linked with genetics. Sometimes when you do these studies, participants might be working on the participants might be working on a depression questionnaire, and they found out that they have depression, and this might affect participants' life events really badly. So it's important to handle those kind of information with care. And there's social implications of reporting scientific results, which is that when you report scientific results, sometimes society might conclude things in a different way. So, for example, when you research about how genetics may contribute to aggression, the society might view it as, oh, aggression is actually from genetics, which is false, but unfortunately, that's sometimes how society works, especially the media. So it is important that we realize that and we prevent that from happening by wording it, by framing the words in the report. So now we'll jump to okay, so I'm sorry for that typo. This is supposed to be qualitative studies. So we'll jump to qualitative studies, and this is the overview of what we're going to talk about. And qualitative study operates in variables, which uses objective measurements. And quantitative data, as we talked before, takes form in quantities. So one important thing to consider when you're researching about when you're conducting a quantitative study would be confounding variables, because this confounding variable can potentially distort your IV and DV relationship, and it is important to control, eliminate, or keep them constant so that you can prevent biases from happening, which can distort your results. By the way, do you guys have any questions? You guys can still hear me, right? Because, the connection before was kind of red, so I was kind of concerned while I was explaining. Oh, okay. Okay. Same. Alright, so since there doesn't seem to be any questions, I'll just continue. So there's 3 common quantitative research methods, which is experimental studies, correlation studies, and correlational studies, and descriptive studies. And the first common one would be experimental studies. So usually, experimental studies are used to determine whether there's a cause and effect relationship between 2 variables. And before you do experimental studies, usually a hypothesis would need to be formulated. Wait a second. Oh wait, actually, a hypothesis typically needs to be used in also in qualitative studies. So you want to screw it? It's okay. Okay, so as you can see, the hypothesis predicts the relationship between the IV and DV, and the experimental hypothesis. So there are two kinds of hypothesis, which is the experimental hypothesis and the null hypothesis. The experimental hypothesis predicts that usually the IV would have effect on DV, while the null hypothesis predicts that the IV will have no effect on the DV. And there are several kinds of experimental designs. The first would be repeated measures design. So how repeated measures design is that it is used to compare conditions instead of groups. So participants usually do all the conditions in the experiment. So they keep on repeat their condition, and they would be able to know all the conditions that they have in the experiment. So the good thing about this is that the results would be normally controlled. So basically the good thing about this is that usually the results of the sample would be compared to their own selves. So the participant variables are controlled, which is good. However, there might be some limitations in when you conduct the experiment, which would be order effects, which means that the order of the condition might affect future results. However, this can be countered, or this can be prevented by counterbalancing, which means that you mix up the order of the experiment. So since you're going to repeat the experiment conditions, demand characteristics might happen, because if you keep on repeating, participants might start to guess. Participants might start to guess what the aim of the study is, or they might get tired of the experiment. So it would lead to expectancy effect or screw you effect. And another thing that might influence the study would be that the materials in the conditions usually needs to be varied. Therefore, that means that sometimes the materials might not be as equal. For example, if you work on like math tests, the questions might vary from one condition to another condition. So the difficulty of the test might not be as equal. So another experimental design would be independent measures design, where participants are randomly allocated to one condition of the experiment, and then if, for example, there are two conditions, the two conditions would be compared to each other. The good side of this is that there's gonna be no such thing as order effect, because you're just going to compare two conditions, and the participants won't be repeating the experiment. And the good thing about doing this is that since the participants are randomly allocated, the potential confounding variables can cancel each other out, because, for example, if this particular group has people who are very good at doing this condition, or if their results of this condition are very good, there might be also people who might have really, really bad results. So they cancel each other out, and the result becomes average. However, as you may know, everyone is different. So if you do independent measures design in a small sample size, participant variability might affect the results. Therefore, turning the turning the experiment into resulting in an experiment which might not be as random and fair. So the last experimental design that we have is matched pairs design. So it's kind of similar to independent samples design, but the participants are randomly allocated to one condition. Wow, seriously. Okay, so before they are randomized, like the independent sample design, they are matched into groups. However, the group matching is not it's not like separate groups, but the group matchings are usually ranked. So for example, they have like this for example, if you have a class and you have the kids who have good grades and you have the kids who have bad grades, and they would start ranking them from 1 till, for example, 1 till 30, and they would start pairing the smart ones and the average ones, and after that they're going to randomize their condition. So in matched pairs design, they're going to compare their results per their respective groups. So since usually when you have a small sample, it would help a lot because of the possible participant variability. And this is also good if order effect cannot be prevented in repeated measures design. However, the thing with doing this kind of experiment is that it's very time consuming because you have to group them first and then test them one by one and etc. So when it comes to sampling in experimental studies or in quantitative studies in general, it's important to find samples that has a good representativeness. So basically what that means is that it has to represent target population. So there are several kinds of sampling techniques. The first one is random sampling. Basically what that means is that every person has equal chances to be participant. Okay, so do you guys want me to explain all the strengths and limitations one by one? Because I'm starting to feel like it's going to take forever to finish this if I explain them one by one. Okay. I mean, I don't mind explaining it, but it might take forever. Just... Yeah, okay. Let me drink for a while. Okay, that feels better. Okay, yeah, since we're having a review, we'll just go over them like briefly, so it won't take forever for me and for you guys too. So as you may remember, random sampling is basically every member of population has equal chances to be participant. The choices are randomized, so anyone can be a participant. And for stratified sampling, in society, there are some characteristics in a sample, in a population, and usually what stratified sampling does is that they consider the proportions of these characteristics, and after considering how much percentage of the characteristics will be in the sample, they would randomize. They would try to get a randomized sample per characteristics, but in like a certain proportion, depending on how often the characteristics occur. So, for example, if you have 10% of the population as 9th graders, that means 10% of your sample would be 9th graders. There's also opportunity sampling. Basically, you just use anyone that's easy to use. Common examples of these would be college freshmen and rats, or usually students, because it's easy to get them. And then there's also self-selected sampling, where volunteers are recruited and picked. Usually in these self-selected samplings, they have like a certain requirement of how the participant should be. Usually in these kind of sampling techniques, they would like require like a particular person to be healthy or to be etc., etc., etc. Okay, so in experiments, we have to make sure that they're credible. And a way to do this is to look at their construct validity, internal validity, external validity, and artificiality. So construct validity is it questions whether your operationalization or your whether your definition is measurable, whether that measurement is legit. Meanwhile, internal validity, it usually questions the quality of the experiment's method. It questions the experiment's conduct. For external validity, they usually look at the outside, which is how well the sample can be used to generalize to population as a whole, which is called population validity, and ecological validity, which is how well the situation can generalize to real life situations. Or another word for it is basically you're testing for mundane realism. And another thing that you can consider, this is from In Thinking, by the way, this is not from the book. Well, but just so that you know, artificiality is basically when situations created is unlikely to occur. So, I think this usually applies for like really, for generally really dumb hypotheses. Apparently, there are like really dumb and weird studies out there. But yeah. Okay, so other than its generalizability, another thing that you can do to evaluate studies would be checking their bias. So there are a lot of biases, especially to internal validity. And the first one would be selection. So basically, selection means that two samples are unequal in the first condition because of a certain characteristic that affects their results. And for history, it basically means that when you're conducting the experiment, there were certain external influences. So, for example, condition A is done on room A. Wait, no, that's confusing. Okay, so for example, there's this music test that is done in the music room for one condition. And then for the other condition, it was done on a classroom. And this is a history bias because there might be things that might influence the study to be different. For example, the surroundings of the study, or the fact that the music room has soundproof areas. And then there's also maturation. So basically, sometimes when you have an experiment and then you test them for the first trial, and then you test them for a second trial, and then during the second trial, they might improve or they might not improve and worsen, but that's actually natural development or fatigue. But then they were mistaken as a result, and this is usually where placebos take in. Wait, no, not placebos. Control conditions. Sorry, placebos are for pill-related stuff. And then there's also testing effect. So basically, what happens in testing effect is so the first DV might affect the following DVs. This usually happens in repeated measures design. So for example, you conduct an anxiety test on the first trial, it's fine, and then on the second trial, they might be less anxious because they are used to it, because they have experienced it in the past, so it's not as anxious for them anymore. And then there's also instrumentation. So, especially if the observer is a human, it's important to consider instrumentation because sometimes the observer, if they're a human, they might feel tired, so they might pay attention less to the stuff that they're supposed to the stuff that they're supposed to pay attention to. And then there's also regression to the mean. So what happens in regression to the mean is basically sometimes during the first trial of the experiment, scores might be very different. And what happens after the scores are very different or extreme is that they during the first study that came out, the scores are extreme, and then during the next studies, they tried to replicate their studies, and then turns out statistically, they're not as extreme as they were thought. And a good way to deal with this would be to have a control group. So, like the results from the initial study's results won't be too different statistically. In an experiment, mortality means that sometimes participants would drop out of the experiment due to certain circumstances. And if the dropouts aren't random because they felt uncomfortable, which invokes them to leave the experiment, it might affect the final results of the study. And then another bias would be researcher bias. So if the researcher believes that the result, the cause and effect would happen, sometimes it might unconsciously or subconsciously affect how the researchers does the study. So it would affect the results of the study. And a good way to tackle this is using double-blind control. So basically, double-blind control is where the tests are administered by someone who doesn't know about the study, and the participants also doesn't know about the aim of the study. So no one knows what the predicted result would be. By this way, researcher bias would most likely not happen. And then participant variability is actually the same with selection. So we'll just, and okay, so the last one would be demand characteristics. So there are 3 kinds of demand characteristics, but the main point of demand characteristics is that the participant tries to figure out what the aim of the study is. So they, after they try to figure out what the study is, they would unconsciously try to confirm to what they think it might be, or they might go against it. So basically, they try to figure out the aim and they try to alter their behavior. So their behavior would be unnatural. And so now we're going to review like the types of experiments that there is. And the first would be true experiments. So the characteristics of a true experiment is that it always has a control group. And the IV and DV have to always be operationalized, which means that you have to know what to measure for the variables. And since it's a true experiment, a true laboratory experiment are always highly standardized, and the condition allocation is always randomized. And then the next would be quasi-experiments, where the IV is usually grouped based on trait or behavior. For example, would be their culture, their gender, or their age. So usually common IV-DV groups like this would be males and females. They usually don't make like IV or DV. They just use existing groups and they try to kind of like manipulate them in some way. But they obviously can't manipulate the pre-existing groups, so they make them do something and then they manipulate that, the stuff that they do. So yeah. Another would be natural experiments. This is sort of similar to field experiments, but they're not quite the same. So natural experiments uses stuff that is outside the researcher's control area. So they cannot control IV at all, unlike quasi-experiments, where you can still kind of manipulate the IV to do something. So usually, natural experiments happen if you're testing about something that you can't really manipulate, or it's unethical to manipulate. For example, stress. They would measure the behavior before and after a variable are introduced. So for example, they would measure the stress levels of someone, and then they would give interventions to these people and they would measure the behavior after they were given interventions. For field experiments, they're usually done literally in the real world, and they can usually manipulate their IV. However, their DV can't be controlled. Okay, so now we're going to talk about correlational studies. Correlational studies, unlike experimental studies, are used to collect data to see the relationship between two or more variables. So, instead of finding the cause and effect, they're trying to find the relationship between the variables. And to determine that, there are three kinds of correlations that you need to know. That would be positive correlation, which means that it's directly correlated. So if X increase, then Y would increase. On the other hand, negative correlation means that it is inversely correlated. So if X increases, then Y decreases. So it kind of goes the opposite way. However, for zero correlation, it means that no correlation is found because the results are scattered all over the place. So the thing with correlation studies, because you can't find the cause and effect, you can establish what causes which. So if you have two variables and you found that they have high correlation rates, you wouldn't know if X affects Y or Y affects X, or maybe there's a third variable, Z, and you haven't found that yet. But all you know is that there's a link between X and Y. So when we're talking about correlational studies, it's important to consider that there's such thing as effect size and statistical significance. So the thing with effect size is that it looks for how big your correlation is. Usually, if the correlation size increases, that means the slope is steeper. That is why it is interpreted as larger. If it has a small correlation size, the graph of the correlation would usually be very wouldn't be very steep. So its correlation might not be that big. And so statistical significance determines the likelihood of a correlation to be a chance. You see, when you do correlational studies, you have to consider how big the population is. And usually, how big the sample is. And usually, if the sample is really big, that means that it has. Wait, sorry. I need a sec. Huh? No. Oh. I am completely sorry. That was my sister, and I didn't click mute. I quit the. Yeah, never mind. Okay, so let's continue. Wait, okay. So, if a sample is big, usually its statistical significance would be very big. Wait. when I mean to say this, I stand corrected. When I mean to say the statistical significance is very big, I mean very highly significant, which means that there's a lower chance that the probability is because of random chance. And usually this is determined by the amount of sample that you have. The bigger the sample, the better the statistical significance. And it's more important to consider both of them when you take account into how credible or reliable a correlational study is. So the limitation of having correlational studies would be that it has no cause and effect. You cannot establish causations in the study, which like I explained before. And then another limitation would be the biases. So there are three kinds of biases that might happen. Number one is variable problem, like I said before. In correlational studies, if X and Y have a good positive correlation, there's still a possibility that there might be C, and you don't know about it because you're only doing X and Y. And there are also situations sometimes when correlational graphs look like a curve. An example of this would be an example of this would be, for example, how effective is it to use drugs? So, for example, if you have a high dosage drug and a low dosage drug, and you try to make a correlational graph, sometimes the high dosage drug would not be very effective. However, maybe the middle dosage drug might be very effective, and then the low dosage drug wouldn't be effective. So it would turn into a curve, and when this happens, the line that you're supposed to be drawing, this line that you're supposed to be drawing becomes a straight line, and it wouldn't be able to identify the curve because it can only be seen before drawing the line. And another thing that you have to consider when you're doing experiments where you compare multiple variables is that there's a possibility that the correlation happens by chance, because if you compare multiple correlations, you're not looking at it contextually, but you're looking at it by quantity. And sometimes those kind of things might happen just because it happened to happen, not because there actually is a relationship between those two variables. So the sampling and generalizability for correlational research is similar to experimental research. So it won't be explained further. The last study that we have in quantitative studies would be descriptive studies. Usually these kind of studies are done before you do correlational studies or experimental studies. So these are done when the variables between two are not investigated. So you're simply approaching them separately before making any assumptions. Alright, so finally, it's time for qualitative study. We're actually working on qualitative study right now. So the SL part is actually done, it's now HL. But I'll continue regardless. So, again, in qualitative study, we use interpretative approach to gain insight and put meaning in behavior. So basically, um, unlike in oh, okay, so unlike in quantitative approach, you do you check for their quantities. You want you want to statistically analyze them. But for a qualitative approach, it's more important to find out the context and the reason behind these contexts. So, um, qualitative approach relies on interpretation and usually the researcher and the sample's perspective. And yes, um, oftentimes, sometimes these interpretations can be biased. However, it's important that they should be acknowledged because it's um, the main the main way of dealing with qualitative studies. So for qualitative studies, there are different ways of sampling from quantitative studies because the sampling is not random, unlike quantitative. So sampling in um, qualitative studies considers or pay attention to the characteristics of the population. And some of these sampling would be quota sampling, propositive sampling, theoretical sampling, snowball sampling, and convenience sampling. And quota sampling usually works in a way of where participants with desired characteristics are recruited until there is until the predetermined sample proportions are met. So they would keep on recruiting samples that they require until their quota are met. On the other hand, propositive sampling is kind of similar to quota sampling, but they simply recruit without taking account of the proportion and sample size. So for theoretical sampling, in these studies, they would continue to sample and sample until data saturation happens. So when data saturation happens, usually no new information or no new insight is gained from new participants. Usually this is highly related to studies that with theories and generally relates to theoretical generalizability. And another sampling technique would be snowball sampling, where participants are asked to invite their friends who are suitable for the study. This usually happens when it's hard to find the participants that they desire or when there are insufficient resources. For example, it's hard to find drug users or drug users, so they would try to do snowball sampling. So they would find one participant and ask that participant to invite their friends because due to the condition of due to the characteristics of the sample. So the last sampling technique would be convenient sampling, where they use easily accessible samples, such as university students. In qualitative studies, the credibility also kind of differs from how we evaluate quantitative studies. So in qualitative studies, the types of credibility would be triangulation, report, iterative questioning, reflexivity, credibility checks, and critique descriptions. So the first credibility would be triangulation. Basically what that means is combining different approaches in collecting and interpreting data. The more variety of approaches there is, the more credible they are, because that means that you're pulling together a lot of different perspectives, which makes it more credible. And as you can see, there are several kinds of triangulation, from method, data, researcher, to theory. And for record, basically means that researchers should make sure that participants are being honest and that their participant is fully voluntary. So they would be willing and not alter their behavior in front of researchers. What that means is that the better the participants are in being willing to explain or answer the questions and not alter their typical answers, the better the report is. Iterative questioning means that sometimes during interviews, there are certain topics with sensitive responses that are needed. And to get these responses, there needs to be rephrasing, because sometimes the participants would answer in a dishonest way to cover up about their secrets. It doesn't mean that we're supposed to force them to answer these sensitive topics. However, we're trying to ensure that they have a safe space for them to answer their sensitive subjects in an honest manner. And since in qualitative studies, it's important to determine researchers' interpretations, it's important to consider reflexivity, where researchers would reflect on the possibility of biases that are made. So there are two kinds of these. One would be epistemological, and the other would be personal, which is explained in the presentation. And then there's also credibility checks. So basically, after interviews, there will be transcripts, and you can check the transcript's credibility by asking participants to review and confirm or clarify what they mean, or the context of what they're trying to say, to make sure that there was an accurate interpretation of what they meant. And the last thing that determines its credibility would be tick descriptions. So in qualitative studies, it's important to have a rich explanation of the details of what happened. So the more details that can be explained, that means the more reliable or the more credible the study can be. Because the more details that they have, the more that they can understand it holistically and by context. So there are several kinds of generalizability in qualitative studies, and three of them would be sample to population generalizability, theoretical generalizability, and case-to-case generalizability. sample to population generalizability happens when you're trying to generalize the qualitative study to the population. And usually this is hard to, it's usually hard to do this since usually most samples aren't a good representation of the target population, since we're only checking, we're only paying attention on their characteristics. And then for theoretical generalizability, basically what it means is that findings, if a finding is found, and if there's a good data saturation, it means that it can be generalized theoretically. And sometimes if it's saturated good enough, then the finding of the study can be used to develop to become a further theory. And then there's also case-to-case generalizability. So in this case, it considers whether the study can be transferred into a new situation, like a different setting, context, or people. This would be, for example, generalizing a study done to university students in America and trying to generalize them to Korean students. So oftentimes, due to its other characteristics, it's hard to generalize them like this. And since qualitative study is highly interpretative, there's a lot of biases between participants and researchers that might be done. So, common participant bias would be Christian's bias, basically the tendency to give positive answers for whatever reason. And to prevent this from happening too often, researchers can try to make open-ended questions neutral and focus on participants' opinions. So so researchers would be able to know if the participants' opinions are indeed positive or it was just a tendency in the first place. And another bias would be social desirability bias. Social desirability bias. So a social desirability bias is that when participants respond to interviews, they would try to respond in a socially accepted way. So this can happen intentionally or unintentionally, and a good way to avoid this or prevent this is by praising the words that they're saying in a non-judgmental way, or by phrasing it on the third person, so they don't feel like it might affect them, their social status. So another bias that might happen, especially if there's a group interview or focus group, would be dominant respondent bias, where one dominant respondent would influence other participants' behavior and responses. So sometimes they might intimidate other participants from talking or steal their chances to talk. And a way to prevent this is that researchers should be trained to keep these kind of participants in check and allow everyone a chance to talk, maybe by turn. The last participant bias that we have would be sensitivity bias. So when participants are talking about sensitive topics, there are times when these topics might be too sensitive for them, so they wouldn't want to admit or talk about the truth, and they would distort these responses. And a way to reduce this distortion is by building a good rapport and trust with the researcher. So in the researcher's side, the researchers also have biases. And the first common bias would be confirmation bias. So this is oftentimes unavoidable because every researcher always has a prior belief, and they would always attempt to confirm those kind of beliefs unintentionally, because that's how humans are. And even though they are unavoidable, reflexivity can help take confirmation bias into account and consider that as a thing that has happened. So another bias would be leading questions bias. Sometimes questions might be encouraging participants to respond in a certain way due to the wording encouragement. And a way to prevent misleading leading question bias, which makes participants respond in a certain way instead of their true way, is by asking neutral, open-ended questions, and make sure that it is worded in the participant's language. So another similar thing that might happen other than the leading questions bias would be the question order bias. What happens in the question order bias is that the question order influences participant responses because humans have the tendency to want to be consistent in what they believe and what they did. And to prevent this from happening, it is important that general questions should be asked before specific questions, and then positive before negative, and behavior before attitude. Another possible researcher bias would be sampling bias. So what happens in sampling bias is that the sample isn't good enough for the research aims. This usually may happen. This may happen sometimes in convenience sampling, because the sample might not be a very good representation of the characteristics. So the last bias that we have here for researcher bias would be bias reporting. What happens in bias reporting is that since this is an interpretation of the researcher, sometimes confirmation bias happens. So the evidence that doesn't fit good enough to the findings of the study sometimes can be represented unequally, basically by lessening its frequency and increasing the frequency of the findings of the study that represented the research. And a good way to prevent this is by reflexivity, integrity, and training to increase the researcher's awareness in this kind of situation. So now we're going to focus on the qualitative research methods. There's observation, interview, focus group, content analysis, and case study. So observation means describing behavior without establishing cause and effect relationships. Usually, The reason why researchers choose observation is because it allows researchers to gain their first-hand experience in this in, in, in observing behavior. And um, usually in qualitative usually in quantitative studies, you are limited from observing the behaviors that people do during the studies. However, in observation, you can observe these studies and interpret the behavior and give context to these behaviors. So there are several types of observation. There are the naturalistic versus the laboratory. Basically, the naturalistic is that it occurs in natural settings. This is usually done for stuff like stress. So usually you can't really experiment on stress. So however, you can still observe stress. So you can observe it in natural occurring settings. However, these kind of settings aren't always 24/7 available. It's not always available. So it can be time consuming to find a good time to observe in natural settings. And for laboratory observations, it's usually done in the laboratory. So it's not in natural settings. And then there's also overt and covert observation. Overt observation is when the participants know that they're being observed, whereas the covert observation is when the participants doesn't know that they're being observed. And then there's also the participant or non-participant observation. When there's participant observation, the researchers are usually involved in the observation in the observed group. So the researchers becomes part of the group and observes as they are part of the group. But for non-participant observation, the researchers would usually observe the group from far instead of getting involved from the group. On the other hand, there's also structured or unstructured observation. So structured observation is when observation is done systematically. An example of this is to have a checklist of behaviors that might be observed. For unstructured observation, the observation is usually dependent on the researcher, but usually researchers would try to observe as much as possible, and whatever the behavior is, usually the seemingly noteworthy behaviors are always described. So the next qualitative research method would be interview. Interview data comes in form of audio or video recording, which gets converted into interview transcripts, and sometimes this includes interview notes. And the reason why sometimes researchers will want to do interviews is because this is one of the ways to get to understand context behind behavior. So, as you can see in observation, you interpret behavior and you observe them. However, in here, you can find out the context behind these behaviors from the person themselves. And an interview is one of the ways to talk about sensitive topics. For example, talk about alcohol abuse. Even though they're sensitive topics, but if the participant is willing to talk about it, then researchers would be able to gain insight about how it feels or whatever they want to research on that kind of topic. So there are several types of interview, actually 3 types of interview: structured, semi-structured, and unstructured interview. Structured interviews are very systematic. They're highly controlled, so they already have questions that are already planned, and since they already have planned questions, it's easy to compare when you have several interviews and you would like to compare them, since it's already a fixed set of questions. However, due to its standardized characteristic, it may seem artificial sometimes, and the questions may seem impersonal or irrelevant because the questions might seem very stiff. So another type of interview would be semi-structured interviews. Usually, these kind of interviews have a set of open-ended questions, and it allows participants to respond freely, and it also allows a degree of freedom for researchers to probe deeper into the responses while maintaining the focus of the interview. However, there's another interview where it's called unstructured interview. So in this interview, there's only the topic and the time specification. And there are no questions set. So the researchers are free to interact with the participants as long as they're talking about the topic. And due to its unstructured nature, sometimes it might reveal more about the participant, because you may never expect anything other than discussion of the topic. So another special type of interview would be a semi-structured interview with a group of people. So in this kind of interview, the interview serves as a facilitator, and the interviewee would encourage people to interact with each other like a natural conversation. So the reason why sometimes researchers will prevent something like this is because since you're being encouraged to interact with other people, it feels like a natural conversation. So it might feel more comfortable than being asked one-on-one by researchers, because it might seem like an interrogation if that's the case. And otherwise, since the conversation flows pretty naturally, it's also a good way to get information from several participants at once. And it is also easier to respond to sensitive questions, because if one person talks about their sensitive question, then their sensitive experience, then other people will start opening up because they feel like, oh, this person has already talked about it. Unlike in interviews, it's like this researcher is trying to like get into your privacy. And in addition, since there are several participants at once, that means that there's going to be multiple perspectives. So these different perspectives, will increase understanding and interpretation of things, which would be good. So after doing the interview, there's also content analysis. A way to systematically analyze text in a rigorous manner would be inductive content analysis. In a nutshell, basically, it tries to derive recurring themes that continuously appear in a transcript. So the first step to do this would be writing the transcript. There are two ways to do this. The verbatim, word to word, or the postmodern, the more popular type, which is basically word to word plus notes about intonation, gestures, or other nonverbal behaviors. So word to word plus context. And after writing the transcript, it's the time for researchers to reread their raw materials. So researchers start to find themes and stick with the transcript's wording. So after researchers found these themes and identified them, they would be confirmed or revised after they reread the transcript. And then after doing it several times, sometimes with different independent researchers, they would do it separately, and then in the end they would decide if some of these themes can be grouped into low-level themes and high-level themes. So these low-level themes are basically themes that doesn't occur as often as high-level themes, which is like the main points. And afterwards, they would try to figure out if maybe these low-level themes can relate to these main points. So so that it doesn't get okay, so usually they do this with different perspectives, so they can compare with each other's results and increase their credibility in analyzing content. After deciding if there are some themes that should be grouped into high level or low level, they finally create a summary table of themes. So this summary of table would have the high level themes, the low level themes, and then the evidence or notes of analysis from the transcript. So now they would start rereading the transcript again, but this time the theme changes will only be done slightly, not drastic, but only slight nudges until data saturations. Again, data saturations mean that no new themes emerges. Finally is reached. And after data saturation, that means that you can finally formulate a conclusion from the summary table. And this conclusion would need to link to the theory of the study, and participants sometimes may be asked to confirm if the analysis results are similar to their perspectives. And sometimes in these content analysis, they might find a new theory, and this would be called grounded theory. So the last type of study that we have here would be case study. Case study is an in-depth investigation of an individual or group. So in case studies, they would use any sort of method to increase their understanding of this particular individual or group. So in case studies, sampling and generalizability doesn't matter anymore because you're only going very deep into this particular individual or group. And usually these case studies are very special because they're usually rare cases. For example, a popular example in the IB psychology would be H.L. Milner, where his brain, one part of his brain got dissected, and it allowed researchers to study his behaviors after his brain got dissected. And the good thing about case studies is that because they're exceptions, sometimes they might contradict the theories that exist in the moment, and it might it it would be very helpful because if the case studies contradicts current theories, that means that um, scientists are given a chance to refine the current studies into a better and more a better and more credible study. Okay, so that's it for today. Um, References are from Oxford Ivy Psychology Course Companion and In Thinking. The Finding Done. Thank you. Thank you so much for coming for today.